Hello, amazing people, and welcome back. Let's look at this question by one of us. Yes, he or she asked that we should do this. So let's do it together so that you will learn. Okay, is this something you can do? If you can do it, let's know your own approach towards this in the comment section. If you don't know what to do, join me as I take you through the best way to answer this. Now, remember, we are given this function of y. This is an exponential function, and we are asked to differentiate it implicitly. Now, when you talk about implicit function, it means that such function, the x and y variables are mixed up. It's not separated. Just like when you have it explicitly, it is separated, like you have y is equal to, let's say, x plus 2. Okay, it's just separated. And in this case, you are differentiating, is a function of x, and you're differentiating it with respect to this x. Okay, so, but when it is implicitly, the function of x and y are joined together, they are combined. So in that case, you are going to differentiate y as a function of the other. Okay, so you are differentiating y as a function of the other, and you differentiate x as a function of the other. And to do that, join us and let me show you what you are going to do. So to answer this, we are going to begin it with solution. Now, this is what we have. We have y is equal to 5 to the power of 3x. So what do? Remember, it's exponential. So what you need to do is to take off this exponent, this power. Remember your rule of log, which says that when you have log a to the power of n, okay, it is the same as using the power to multiply, so to give you n log a. Now, but when we talk about differentiation, we use the natural log. The natural log is what we call ln. So we are going to have it as, if we have ln a to the power of n, it simply means do this. So we are going to have n ln a. Did you see that? So we are going to apply this here. And to do that, we are going to do it to the both sides. So we are going to take the ln of both sides. So we are having here ln y is equal to the ln of 5 to the power of 3x. Now, what do? So in that case, if we are taking the ln of this, we apply this. So we're going to have ln y is equal to, use this to multiply. So we have 3x ln 5. Did you see it? So what do you do here? This is where the implicit differentiation comes in proper. So in this case, we are going to differentiate y as a function of the other, and you do same to the x. So how do we differentiate ln y? When you have ln y, you differentiate it, it gives you 1 over y. But we are differentiating implicitly. In that case, when you differentiate ln y, you are also going to differentiate y using chain rule. Did you understand it now? So we are not just differentiating ln y to have 1 over y. We are differentiating this y also, because we are seeing it as two functions in one. So differentiating ln y gave us 1 over y. Then we are going to differentiate y also. And when you differentiate y, we're differentiating with respect to x. You know, when you differentiate y with respect to x, it gives you dy dx. So here we're going to have this, you add dy dx to it. I hope this is cleared. Okay, now let's come to the right side. We are going to differentiate this right side, and to do this, these are two separate functions. You see 3x and ln 5. And what does it remind you? It reminds you that when you have two functions multiplying, you see these two functions are multiplying each other. And when you have u to multiply v, according to your rule of differentiation, which is the product rule, it says you are going to have v du plus u dv. This is your product rule. You use it for when two functions are multiplying each other. So in this case, we are going to have this as our u and this as our v. So let's apply this rule here. So we're going to have v, our v is ln 5. So we're going to have ln 5, okay? So we can take it up now. So this is going to give us, let's take this up. So we're going to have 1 over y dy dx is equal to, we're applying this. So we have v is ln 5. So we have ln 5, okay? Then multiply by du. Du means to differentiate your u. So we're differentiating u with respect to x because a function of x. So let's differentiate this 3x. And when you differentiate 3x, remember your rule of your rule of differentiation, the formula method, which says if you have y to be equal to x, to differentiate it, you have dy dx gives you, and this is raised to power n, use the power to multiply, you have nx, you take 1 from the power. Did you see it? So we are going to apply this in differentiating 3x. So when you are doing it, you see when you have 3x means 3x to the power of 1. So use this one to multiply. In that case, you have 3x, take 1 from 1, it will be 0. So it gives you 3x to the power of 0. So when you differentiate 3x, it gives you 3x to the power of 0. And x to the power of 0, according to your indices, is 1. So in that case, you're just simply saying 3x. I hope this is cleared. Okay, let's just leave it there for formality purpose, okay? Now we've done this. Let's now treat this. So we have plus. What is your u? Your u is 3x. So we have 3x. We are multiplying with, what is my dv? The dv is to differentiate length 5. And length 5 is just a constant because it does not have any variable. I hope this is clear. So when you're differentiating a constant, according to your differentiation, if you want to know more, I will leave the link in the comments. You do what? Constant gives you 0 when you differentiate. So length 5 is simply a constant, which will give us 0. So we're going to now have 1 over y, okay, dy dx is equal to, these are together, so we have length 5 is multiplying 3x. X to the power of 0, like we said, is 1. And when you multiply 1 by 3, gives you 3. Plus this multiply 0 is 0. So in that case, we are going to have 1 over y dy dx, okay, is equal to length 5 multiplied by 3. So let's remove this y. To remove it, you are going to multiply both sides by y. So we have y, we multiply 1 over y dy dx is equal to length 5 is multiplied by 3. So this, and you also multiply this by y so that the equation will be balanced. So this will cancel, and 1 multiplies dy dx is going to give you dy dx, okay? So when you now have this, you have length 5 is multiplying 3, which is multiplying, what is your y? Your y from the question is 5 to the power of 3x. So return it. So in this case, you are going to conclude that your dy dx is equal to, you can now bring this together to give us 3 multiplying 5 to the power of x length 5. And this becomes your answer. And I hope this helps you a lot. Let's know how much in the comment section. Remember, you can subscribe for the more you get. Give this tutorial a thumbs up and share with your colleagues. I will see you in our next class. Bye-bye.